on the track on my face.
Hello students, today we are going to learn indefinite integration which are based on standard trigonometric substitution. What are those standard trigonometric substitutions? Let us understand. This is expression and accordingly we have to give some substitution. So when you will have this expression a square plus x square in numerator or denominator anywhere a square plus x square, then there is a one point, there is a one theory which you can use. I am not saying all questions can be solved by this substitutions only, but this is also a thought you can apply. So a square plus x square, if you use x is equal to a tan theta, okay, put a tan theta over here, it would be a square tan square theta, and this is a square. A square you can take common, 1 plus tan square theta, which is a square cot square theta. So this is one term, this is second term. So if you combine with this substitution, it will be one term. So this is the beauty of substitution. So x equals a tan theta you can use, or x equals a cot theta you can use. We generally use a tan theta. Now a square minus x square. So this is the logic. You are not going to just learn this one. You will set in your mind which substitution would be better for this. Here tan theta will not work because a square tan square, a square you will take common 1 minus tan square. 1 minus tan square is nothing, but 1 minus sin square is something, right? 1 minus cos square is something. So accordingly x is equal to a sin theta we can take, or x equal to a cos theta we can take. If we take a sin theta, then a square sin square theta, a square we can take common 1 minus sin square, that is cos square. So similarly for a cos theta also. Now x square minus a square, if we take sin theta, then a square we will take common sin square theta minus 1. Then if it is in root, then there is a problem. This expression, or if it is root, then there is a problem. So what we can do? We can take x equals a sec theta. Why a sec theta? Okay, let us check. A square we can take common sec square theta minus 1. 1 plus tan square theta is sec square theta. So sec square theta minus 1 is tan square theta. So solvable. So x equals a sec theta, or x equals a cosec theta also. Because cosec square theta minus 1 is cot square theta. Now this is a minus x over a plus x. So here you have to use x equals a cos 2 theta. Why 2 theta? Let us understand. A minus a cos 2 theta over a plus a cos 2 theta. So a we can take common and it will be cancelled. Then 1 minus cos 2 theta, 1 plus cos 2 theta. 1 minus cos 2 theta, 2 sin square theta. 1 plus cos 2 theta, 2 cos square theta. 2 cancel. Sin square theta over cos square theta, tan square theta, root tan square theta is tan theta. So see, this is so complex. When we have substituted this one, then it became only tan theta. So this is the beauty of substitution. Now 2x over 1 minus x square, or 2x over 1 plus x square, or 1 minus x square over 1 plus x square. If you observe carefully, then you will find this is nothing but some formula. If you put x equals tan theta, then check 2 tan theta upon 1 minus tan square theta. This is tan 2 theta. 2 tan theta upon 1 plus tan square theta, sin 2 theta. 1 minus tan square over 1 plus tan square, cos 2 theta. Okay. So this is a substitution. Now we will understand some examples which are based on these results. Okay. For example, we have to solve this. Integration of 1 over a square plus x square raised to 3 over 2 dx. Now we have to solve. Then what would be our first step? Starting point is the main point for any question. So a square plus x square. So here we have to think, okay, a square plus x square, it means x is a tan theta, right? So let x equals a tan theta. Then differentiate it. Then x derivative dx, a tan theta is sec square theta and theta is d theta. Then I equals, this dx will be replaced by a sec square theta d theta over, this is a square, and x square means a square tan square theta. and raised to 3 over 2. So this is 3 over 2. Okay. Then I, this is a sec square theta d theta. This is a square and a square. We can take a square common. So a square and raised to 3 over 2. So this is 3 over 2. Now this is 1 plus tan square theta. 1 plus tan square theta is sec square theta. So sec square theta, and this is 3 over 2. So this 2 and this 2 got cancelled. This 2 and this 2 got cancelled. So we got, this is a cube and a over a cube. It means 1 over a square. It means 1 over a cube, 1 over a square we got. Now this is sec square theta, this is sec cube theta. Okay, so 1 over sec theta, it means this is cos theta d theta. Now I equals 1 over a square, cos theta integration is sin theta. So this is sin theta plus c. Now we have to replace this sin theta in terms of x. How? Let us understand. This is very important. This tan theta I can write, tan theta I will write x over a. Okay. So this is, okay, this is theta, this is p, perpendicular, this is base, then hypotenuse would be x square plus a square, right? Then tan theta is x over a, then this is a right angle triangle, this triangle can possible. Then 1 over a square, from this triangle sin theta would be what? Sin theta would be x over root x square plus a square plus c. So finally I would be x over a square root x square plus a square plus c. So this is a question which is based on trigonometric substitution, a standard trigonometric substitution. It is not like trigonometric identities and formulas. Okay, now we are going to learn 9 important formulas which are based on whatever we have learned right now. I mean standard trigonometric substitution. The first is 1 over x square minus a square. So first I will write all formulas. This is 6. After this I will write 3 more formulas. So first I will write all formulas. Then I'll give you a technique how to derive that. So 1 over x square minus a square. Answer is 1 over 2a ln x minus a over x plus a mod plus c. Then this is 1 upon a square minus x square, which is 1 over 2a ln a plus x over a minus x plus c. Third one, 1 upon a square, 1 upon x square plus a square integration, which is 1 upon a tan inverse x by a plus c. Okay. Now 1 upon root x square minus a square. It has ln x plus root x square minus a square plus c. 1 upon root a square minus x square, which is sin inverse x by a plus c. And 1 upon root x square plus a square means ln x plus root x square plus a square plus c. Okay. So these 6 formulas, actually these 3 and again these 3, just we have applied root, this one again root and again root. Okay. Now we have 3 more formulas which I will write here. Those will be same thing but in numerator. So this is 6. Now 7th. This is root x square minus a square dx. Then 8th one, root a square minus x square dx. Then 9th one, this root x square plus a square dx. Okay? So we have to learn these. Try to understand. This is very important. Try to understand. When we have root x square minus a square, then what is the answer? Answer is x over 2 root, same thing, root x square minus a square I have to write, then minus a square by 2 ln x plus root x square minus a square plus c. So x by 2 is here and minus a square by 2, otherwise just I have used this result, x plus root x square minus a square over here. Now this root a square minus x square, answer is x by 2, then this whatever question, root a square minus a x square and then plus a square by 2. Yeah, here you have to learn this is plus a square by 2. So this is plus a square by 2 and this one is sin inverse x by a. So this is sin inverse x by a plus c. And ninth one, root x square plus a square. The answer is x by 2 root, this is the question, x square plus a square by 2 and then ln, when it is in denominator then what's the answer? Ln x plus root x square plus a square mod plus c. So these three again we got. So these three are very lengthy formulas, but you have to learn. This is very important. Okay, so one point is to learn. Second point is to understand how these formulas are derived. So total we have 6 and actually we have 3 sets. So from one set I'll do one formula. So and if you try then you can get other formulas also. So let us understand. Okay, first one is 1 over x square minus a square dx. This is our first formula. So here I have two methods. First, substitution one. So method one is a substitution one. X square minus a square. So here let x equals a sec theta, right? Then dx would be a and sec theta integration, sec theta derivative is sec theta tan theta d theta, right? And here x square minus a square would be a square sec square theta minus a square. A square we can take common. So sec square theta minus 1 is tan square theta. So now this became, this is I for example, this I became dx is a sec theta tan theta d theta over x square minus a square, already we found a square tan square theta, right? Now this a over a square, which is 1 over a, and this is tan theta, this is tan square. So I got sec theta over tan theta. So sec theta means 1 upon cos theta and tan theta means sin theta upon cos theta d theta. So got cancelled. I got 1 over a cosec theta. Okay. So I got 1 over a cosec theta. Now what is the integration of cosec theta? It was required to learn. So here cosec theta is ln cosec theta minus cot theta plus c. Okay. So this is my answer, but not in terms of theta. We have to give answer in terms of x. So how can we get in terms of x? That is again understand. Sec theta is sec theta is x over a. Okay, sec theta is x over a. It means sec means how much? Base over hypotenuse over base. So this is hypotenuse and this is base. So what is perpendicular? X square minus a square, right? So sec theta is hypotenuse over base, hypotenuse x base a, and perpendicular is root x square minus a square. Okay, come to this point. So then I equals 1 over a ln cosec theta. Cosec theta is hypotenuse over perpendicular. So this is my hypotenuse over root x square minus a square minus cot theta. Cot theta is again base over perpendicular. What is base? Base is this. So a over perpendicular is x square minus a square and plus c. So now I got I equals 1 over a ln. This is x minus a and this is root x square minus a square, which I will write root x minus a times root x plus a plus c. Okay, then I will be 1 over a ln. This is x minus a and this is root x minus a. So if you cancel, then you will have root x minus a over root x plus a plus c. Okay, then again I will be 1 over a ln x minus a over x plus a raised to half mod plus c. And finally you have I equals 1 over a, and this half will come over here because of log property, and then this half will be here, and this is ln x minus a over x plus a plus c, and I equals 1 over 2a ln x minus a over x plus a plus c is the answer, where I have applied concept of the standard trigonometric substitution. This is method 1. But this particular question can be solved quickly by observation. Okay, so let's do that. Here we have to observe. So I equals 1 over x minus a times x plus a I can write. Okay, because of factorization. So x square minus a square, x minus a, x plus a I can do. Now I equals, I will write 1 over x minus a, I will give a space, 1 over x plus a. Okay, and then I will try to solve it by adding, and we can solve mentally. This x plus a will come over here, this x minus a will come over here, minus a plus a will cancel, x plus x, 2x we will get. So here 1 is available, but here we got 2x. So there is a error over here. So plus sign does not work. Okay, then I will put minus sign. If I put minus sign, then here x plus a will come, and here x minus a will come. Because of this minus, it will be minus x plus a. So minus x plus x cancel, a plus a, 2a will be there. But again this is 1, but this is 2a. But 2a is constant. So I can write 1 over 2a over here also. So now if you solve, then you will get 2a upon x minus a times x plus a. This 2 will be cancelled by this 2a, and overall this will be same. Okay. So this I equals, I got 1 over 2a, and this is 1 over x minus a minus 1 over x plus a dx, which is 1 over 2a, and 1 over x integration is ln x. So this is ln x minus a minus ln x plus a plus c, and finally we got 1 over 2a ln x log, because of log property, log m minus log n, log m over n we got. So ln x minus a over x plus a we will get and plus c. So this is my answer again. This is second method. This method is based on observation. Now, so first, second and third. First I have done, second and third you guys can do based on substitution, or you have two methods indirectly, substitution or logical. So one of them will work definitely. Now we will do fourth one where I have applied root in denominator. But fourth one was this x square minus a square. So I don't want to do this one. I want to do fifth one where it was, I think, a square minus x square, right? So let's do 1 over root a square minus x square. Now there is no observation. Observation won't work. Only substitution will work. So a square minus x square. So x is a sine theta. Yes. Let x equals a sine theta. It will work. Then dx is equal to a cos theta and d theta, and a square minus x square term would be a square minus x square, a square, and x square is a square sine square theta. Now a square we can take common. Now 1 minus sine square theta, which is cos square theta we got. We can consider this I. Now I equals, I got dx as a cos theta d theta over and root a square minus x square, which I have solved already, a square cos square theta I got. Now this I equals, I got a cos theta d theta over, this is a cos theta again, cancel. So I equals, I got d theta, I equals theta plus c. Okay, so we need to find theta. So this is my x equals a sine theta. So sine theta is x over a is sine theta. So from here, theta is sine inverse x over a. So now I equals sine inverse x over a plus c. So it was a question. 1 over root a square minus x square. What is the formula? Sine inverse x over a plus c. So I have derived fifth one. Now 4, 5, 6 based on root. One of them I have done. Rest 2 you guys will do. Now come to 7, 8, 9. So 7 was root x square minus a square. 8 was root a square minus x square. And 9 was root x square plus a square. So I am going to do right now root x square plus a square. This is root x square plus a square dx. So here again no, observation will work. We have to use formula. Sorry, we have to use okay, now this is a ninth one. Here no observation will work. We have to use substitution. So let x equals, which one you will use? X square plus a square or a square plus x square? A tan theta or a cot theta? I will use a tan theta. X equals a tan theta. Then dx is a sec square theta d theta, right? Then, and this is I also. And this is x square plus a square. So write x square plus a square, which is a square tan square theta plus a square. Now a square will take common, tan square theta 1. 1 plus tan square theta is sec square theta. So I got sec square theta. Now this I will be root x square plus a square, which is a square sec square theta times dx. Dx is a sec square theta d theta. Okay. Now I got a, and this is root a square, which is a square totally, and this is, I have sec theta and this is sec square. So total I got sec cube theta d theta. Now the point is how to integrate sec cube theta, right? So sec cube theta will be integrated by one method that is called by parts method, which I will explain in next class, because right now I have not explained by parts method. By the way, by parts method directly can be applied over here, and this question can be solved by easy way also. So when we will learn by parts method, then I will explain this problem again by using by part method concept. So by more or less we have to use by part method over here directly or over here. But what I intended to use this concept, because I had explained standard trigonometric substitution. That's why I have used this. But for example, if question comes to me to integrate this, then I am not going to use this one. Directly I will use by parts method over here. That is root x square plus a square times 1. There is a certain method, there is a certain way to solve. So we will see that method also, and again this problem in next video. Thank you very much.